Welcome back, everybody. We have a couple more left in chapter 11, and right now we're going to do multiplying and dividing radical expressions. Okay, are these two expressions equivalent or equal? Well, you know what? They're not, because the square root of 2 is going to be 1 point something. If you times that by 8, it's not going to work. And here, if I do 8 multiplied to 2, I get 16. And now I'm able to square root 16 and get 4. So I would say these are not equal. So in this lesson, we're going to make sure that we multiply things out and simplify things before we judge them. All right, here's what we're going to do. We're going to multiply these together. And if they're both underneath the radical, or we would say if they're both radicans, they can share one radical. So what we can do is say 8 multiplied to 6. Now, that would be the same as 48. So, now I can break 48 down. I look at my list of perfect squares, and I know that 16 can go into 48 3 times. So now I'm going to square root the 16, and I get 4, and then my square root 3 will stay right there. Let's do our next one. So if I'm squaring this, no shortcuts here. I want you to write the parentheses twice. Okay? So we're going to do 3 square root 7 multiplied to 3 square root 7. Then you can do the associative property and get rid of the parentheses, and then you can do the commutative property and move them next to each other. And 3 times 3 is 9. And then the two 7s can share the same square root. So now I have 9 multiplied to the square root of 49. Well, if I look at the square root of 49, I know that the square root of 49 is 7. So now this 7 is going to come out, and I'm going to multiply it to the 9. I end up with an answer of 63. Instead of doing square root 49, I could have circled these two 7s, and because I had a pair of them, I could bring one out. Same thing, same answer. All right, let's try this one. If I'm multiplying these two radicans, I can put them underneath one big radical, and then I can do commutative property, and I can move them next to each other. So 3 multiplied to 12, and then y multiplied to y. So I can circle my two y's, so that will be able to come out. And 3 multiplied to 12 is 36. So I can square root 36. The square root of 36 is 6. And I have one pair of y's. So everything's out of the radical. It doesn't always happen that way. Here, I'm going to square this parentheses. Like I said before, please write it twice. So, write 2 square root 5 multiplied to 2 square root 5. Then we can drop the parentheses and put the 2's together and put the square root 5's together. 2 times 2 is 4. The 5's will go together underneath the radical. And if I want, I can do this. I can say I have one pair of 5's. So I can take the 4 and bring the 5 out. If you don't like doing it that way, what's the square root of 25? The square root of 25 is 5. Same answer. Lastly, I multiply these together. 4 multiplied to 5 is 20. This answer is 20. All right, now we're going to do the distributive properties. So basically I'm going to do square root of 3 and multiply it to the 7 and then multiply it to the negative square root 8. Here's what it looks like. I get square root 3 multiplied to 7 and then the minus sign and then square root 3 multiplied to the 8. Let's put these together and let's rewrite this. So I have 7 square root 3 minus the square root of 24. Let's try and break the 24 down. Well, 24 is really 4 multiplied to 6, and I can square root this 4 and say it's 2, so what's left inside is the square root of 6, which I cannot break that down. So here's my answer, and I am not able to add these together because they are not the same radical or radicand. Let's try this one here. Distributive property first. Take the square root 2, multiply it here and here. So I have square root 2 multiplied to square root 8, and then I have square root 2 multiplied to square root 18. Let's have them share a radical. When I do that, I end up with 2 times 8 is 16, and 2 multiplied to 18 is 36. Well, now I can square root easily. The square root of 16 is 4, and the square root of 36 is 6. All I have to do is add them. 4 plus 6 is 10. Well, this answer ended up being 10. Crazy. Let's do it again. Distribute the 5 to both of these. Here I wrote the square root of 5 multiplied to the square root of 10. Now here I took the square root of 5 and I multiplied it to the square root of 3. I put the 4 first. I did commutative property. I just decided to take the 5 and multiply it to the square root of 3 because they're both square roots. Okay, let's put these radicands under one radical. So I end up with square root of 50, 5 times 10, and then the square root of 15, 5 multiplied to 3. Now, I'm going to try and simplify this. So I know 25 can divide this. The square root of 25 is 5, but square root of 2 will stay, and I cannot square root 15. I can't pull anything out of that. So here's my final answer. I'm not able to add those together. One more. Let's distribute this to each term. I did 5 square root of 5 multiplied to the negative 4. Then I did 5 square root of 5 multiplied to the 6 square root of 5. Let's regroup these, do commutative property, group things together. I'm going to put this with this. So I put the 5 multiplying with the negative 4 because they're coefficients. And I took the 5 and multiplied it to the 6 because they're coefficients. And I have my 2 radicands multiplying. So this will equal negative 20, and then I have square root 5, that's still there, and 5 multiplied to 6 is 30, and now I'm going to share a radicand, so 5 multiplied to 5 will go right here. If I keep going with this, I end up with 5 multiplied to 5 is 25. Well, I know I can free that out, so I can say the square root of 25 is really 5. Now remember what we do. I take that 5 and I'm going to multiply it to 30. So 5 multiplied to 30 is 150, and then I can bring down my negative 20 and my square root 5, which is next to it, and put a plus sign here. I'm done. I cannot add anything else. I'm all done. That's my answer. All right, I'm going to show you something that's really in Chapter 7 that we haven't learned yet. We're going to go learn it next week. It's called FOIL, but what I call it is distributive property twice. So when we have a parentheses with 2 terms in it, and we multiply that to another parentheses with 2 terms, watch what we do. We take this 3, and we're going to multiply that 3 to the 2 and to the negative 8. It looks like this. 3 multiplied to 2, and then I say plus, because we have a plus sign, 3 multiplied to the square root of 8. But I'm not done, because after I do that, I need to take this negative square root of 8, and I need to multiply that to both of these. It looks like this. Negative 1 multiplied to 2 is negative 2, and then the square root of 8 will be with it. Next, I'll do negative 1 times of square root of 8 multiplied to square root of 8. So I get negative 1 square root of 8 multiplied to the square root of 8. So what I did there was I distributed twice. You can see my red lines and my blue lines. That's all I did. Now let's simplify and combine like terms if we can. What I did was I said that 3 times 2 is 6. 3 square root 8 will wait, minus 2 square root 8 will wait on this. The negative 1 will just be here, and what's 8 multiplied to 8 is 64. They're still in the radical. Now, I can say that 3 square root 8 minus 2 square root 8 gives me 1 square root 8. And do I know the square root of 64? The square root of 64 is 8. Lastly, I'm going to look here. I see that these are both constants. So what I'm going to do is do commutative property. I'm going to move this 6 over here. And I'm going to add that, and I end up with 1 square root of 8. And negative 8 plus 6 is negative 2. Here's my answer. So this ended up equaling square root of 8 minus 2. On this next one, it says that this parentheses is squared. Please write down what I write down. I want you to rewrite it so it looks like this. It means do 4 plus the square root of 3 and multiply it to itself. 4 plus the square root of 3. So let's do the distributive property. I'm going to multiply this by 4 and this by 4. Now I'm going to take the square root of 3 and multiply that to 4 and that to the square root of 3. Now I'm going to simplify. 4 times 4 is 16. And 4 square root 3 plus 4 square root 3 will give me 8 square root 3. Here I have a square root 3 multiplied to a square root 3. So that's going to give me the square root of 9. I can square root the square root of 9 because the square root of 9 is really 3. So now I have 16 plus 8 square root 3 plus 3. Well, I can add the 3 to the 16 and get 19. And I end up with 19, and then I need to include this, 19 plus 8 square root 3. So it's this parentheses squared. So what does that mean? It means write 2 of these parentheses. Now let's do distributive property twice. We're going to multiply the 3 to the 3 and the 3 to the minus square root of 2. Next, I'm going to multiply the negative, be careful, the negative square root of 2 to this and to this. I ended up with a negative 3 because of this, negative 3 square root of 2, and the negative multiplied to a negative is a positive, and I have 2 square root 2's here. Let's simplify. I know that this equals 9, and then I know that negative 3 square root 2 minus negative 3 square root 2 would be keep, change, change. That would give me negative 6 square root 2. Here I have square root 2 multiplied to square root 2, which is square root 4. Just like before, I know the square root of 4. It's 2. And I have 9 minus 6 square root 2 plus 2. I'm going to put this positive 9 with this positive 2 and get 11. So I have 11 minus 6 square root of 2, and here's my answer. Okay, sometimes, remember the rules for radicals? You cannot have a square root or a radical sign in the denominator. And if that happens, we do something called rationalizing the denominator. Basically, here's what you do. If you have a square root in the denominator, what you're going to do is multiply the top and the bottom by that square root, because really the square root of 7 over the square root of 7 is the same as 1. So that's the same as multiplying by 1, so that should not change this at all. So when I multiply the top and the bottom by the same thing, it looks like this. The square root of 7 times the square root of 7, we can put them underneath the same roof, and we get the square root of 49. What's the square root of 49 equal? Well, it equals 7. Notice the denominator does not have a square root anymore. On the top, I'm going to do 3 multiplied to the square root of 7. So 3 multiplied to the square root of 7 is just 3 multiplied to the square root of 7. Can't do anything. Here's my answer. I cannot reduce because this is in jail and this is not. This is inside and this is not. Here's my answer. Let's practice. Here I see a square root of 3 in the denominator. That's not okay. So what I'm going to do is multiply the bottom by square root 3 and the top by square root 3. When I multiply the top by square root 3, I get the square root of 33, because 3 times 11. Here I get the square root of 9. but the square root of 9 can be simplified, and the square root of 9 is 3. Here's my answer. I cannot reduce this, even though it looks like I can. I cannot, because this is a radical, or radicand, and this is not. Now let's look at our next problem. I see the square root of 80. Now, I could break that apart before I start, and I'm going to do that just to help things. So I'm going to break this 80 apart. I know that the square root of 80 is really 16 multiplied to 5. That gives me 80. And the square root of 16 is 4, and I'm left over with the square root of 5. Now, if I take that and put it with this 2 that was already there, I multiply the 2 to the 4, and I get 8, and now I have 8 square root 5. That's what the top really equals if I break it down. I still have a square root in the denominator. I need to get rid of that. So what I'll do is multiply the bottom by square root 7 and the top by square root 7. When I multiply the bottom by square root 7, I end up with a square root of 49, but we know that the square root of 49 really equals 7. Here, all I need to do is multiply the 5 and the 7 together because they're radicands. The 8 is just going to be on the side. So 8, then 7 multiplied to 5 is 35. Square root 35. I cannot reduce that, so I'm done. Okay, let's try this one. I notice that the square root of 20 can be broken apart, so I'm going to do that. So I took the square root of 20, and I knew that 4 multiplied to 5 is 20. So I broke out the square root of 4 is 2, so I have 2 square root of 5. So 2 square root of 5 is really the square root of 20, so I'm going to use that instead. Now, remember, the rule is you cannot have a square root in the denominator, so all I need to multiply by is the square root of 5. The 2 I don't have to worry about, so I'm going to multiply the top and the bottom by the square root of 5. Here's what it looks like. On the top, I did 5 multiplied to 13 is 65, so I have the square root of 65m all inside. Here I did 5 multiplied to 5 is 25. It's still inside for now. And then the 2 will just multiply to the invisible 1. Let's break this out of jail. So what's the square root of 25? That's 5. And when I break it out, it needs to multiply to the 2. So I end up with 10. So I end up with 10 in the denominator. The numerator is right here. Square root 65m. I cannot reduce because it's in the radical. I'm done. One more. Let's break this 12 apart. When I break the 12 apart, it becomes 4 multiplied to 3 is 12. I can square root 4 and get 2, so I end up with 2 square root 3. I'm going to write that right here, 2 square root 3. That's really 12. Now, all I have to do is multiply by the square root of 3, because that's the only number being square rooted. The 2 is not being square rooted. So now here's what this will look like. I end up with 3 times 7 is 21, 21a, and then the 3 times 3 is 9. It's still being square rooted, so I'm just going to take care of that. The square root of 9 is really 3. I'm going to multiply that to my 2, so I end up with 6 in the denominator, and the numerator is square root of 21, a over 6. So here's my final answer. Here are the practice problems. Remember to do distributive property, and here do distributive property twice. Bring any questions you have in class next time we meet. Take care.